No. All right, in your packet, turn to the page that's got just random handwriting on it. All right, so we're going to learn about a bunch of different things today. One thing is interval notation. And so interval notation looks like an ordered pair, like you've been doing like for your max and min. It's not. An ordered pair is an X and a Y. That's a point on the graph. Interval notation are two X's. And the interval is all the numbers that fall in between those two X's. So it's kind of hard to distinguish the two in your brain. But try to remember this is going to be two X's, and the number on the left is the smallest X value that's in your interval. And then the number on the right is the largest X value in your interval. All right, so what we're going to learn today are finding intervals of increasing and decreasing. So increasing is when, if you're reading it from left to right, it's like you're going uphill. So for instance, if I wrote the word increasing right here, as I'm writing, each letter is going up. That's what increasing looks like. So from here to here, that function is increasing. So write that on yours too, please. All right, and then decreasing is when, like, if you're reading it from left to right, you're going downhill. So this section right here, that is all going to be decreasing. All right. And then on this particular graph, I have another section that's increasing because I'm going uphill. Now, one thing it says, like maybe on the first page, is that the turning points, the maximum and minimum points, define where the function is increasing or decreasing. So that's where it changes over. The max, like this function is increasing until we reach the maximum. Then we start decreasing. So if we were going to guess the x value where that maximum is, it doesn't have to be exactly. What would you guess that is? Okay. So we're going to say x is -3 at this maximum. All right. What about this minimum? What x would you say? 2. All right. Now, when we're doing these intervals of increasing and decreasing, we only care about x's. We're not going to even talk about the y values. We're only going to talk about the x values. So what is, like, if this graph is going to keep going forever to the right, what number is forever to the right? It's not really a number. It's like an idea of a number. Do you guys know? Positive infinity. So over here, I'm going to put an infinity on the right of my x-axis. What about forever to the left? Negative infinity. So I'm going to put a negative infinity on the left of my graph. And so these numbers right here are the only numbers for this problem that I'm going to use in my intervals. Only the x's where it changes over from increasing to decreasing, or infinity or negative infinity. Okay, so let's talk about increasing. So this graph, when it becomes a graph, it's increasing. And so that's going to be as far as we can go to the left, the graph is increasing. So I'm going to start with negative infinity. That's going to be the smallest number in the interval. And it's going to take a minute for this to make sense. And this graph is going to be increasing, increasing, increasing until I get to what x value? -3. Good. So that's one of the intervals that is increasing. But we have another one. All right. So I know I'm increasing on this interval right here. So the x value where I'm going to start increasing is this x value, that's 2. And then I'm going to be increasing forever and ever and ever to the right. So what's forever and ever and ever to the right? Infinity. All right, so I'm also going to have intervals of, or one interval of decreasing. So I'm talking about this section right here. So between what two x values is that section? -3 and 2. So I'm decreasing from where x is -3 until where x is 2. Right. So that's what we're doing today. And we're going to do this for all those ones that you've already found the max and min of. Well, we're going to do this one under here too. All right, so I already know as far as I can go to the left is negative infinity. I'm going to use that. All right, where do you want to guess this x is? You just want to do exactly -3. So we have a min when x is -3. All right, we're going to say we have a max when x is -1, close enough. And then we have one more min when x is 2. And as far as we can go to the right is positive infinity. When we do our intervals, those are the only numbers that we're going to use. Okay, so I am going to write, I think I'm just going to highlight. So I'm going to highlight my increasing pink and my decreasing blue. And if you guys want some highlighters, I have a ton over there if you want to use them. But I know, like, if you're reading, if you're like walking along the graph from left to right, that is increasing. And so is this. And then everywhere else on the graph, we're falling. You're going downhill. That's decreasing. That's decreasing. Okay. So I'm going to start with this first pink guy right here. What's the x value where this graph starts increasing? -3. And what's the x value where it stops? It's actually going to stop right here. So -1. All right, and then the graph is going to decrease for a while, but we pick up increasing again when x is 2. And it's going to be increasing forever and ever and ever to the right. And forever and ever and ever to the right is infinity. All right. Let's look at decreasing. So when the function becomes a function all the way to the left at negative infinity, we're decreasing. So that's where the function starts decreasing. Where does it stop? -3. Good. All right. And then right here at this max, we start decreasing again. That's when x is -1. And we stop when x is 2. All right. So we're going to go back in the packet a couple pages. So this is the back of the first page. And I'm going to write out a lot of things on the graph. You don't have to if you don't want to. I feel like it's going to help you though. So I want you guys to remember that we're only using the x's. So I know the x at my maximum is this number right here. So I'm going to put that up here at my maximum. I'm going to say that x is equal to 0.71. All right. And then I also know the x at my minimum is 3.29. So I'm going to put that there too. All right. And then I also know as far as I can go to the right is infinity, and as far as I can go to the left is negative infinity. Okay. And so this one, I know I'm increasing right here and right here, and decreasing right here. Okay. So my first increasing interval, at the very end of the function on the left, I know that it starts increasing. So as far as I can go to the left is going to be my negative infinity. And I'm going to be increasing until I get to this x value, which is 0.71. All right. Then I have another section increasing. So I start increasing at this minimum, which is where x is 3.29. And I'm going to increase forever and ever and ever to the right, which is positive infinity. All right, and then for decreasing, I start decreasing at this x. And then I decrease until I get to the minimum, which is when x is 3.29. All right, so you guys have pretty much done the work to get the maximum and minimum points. Now it's just like using those to do your intervals of increasing and decreasing. Now what people do wrong a lot is try to use the y. Please don't use the y today. No y's, only x's. All right, so let's look at number 1. All right, so what I'm looking at, what I did, I guess a couple of days ago, I know that at my maximum, the x is 0. And I know that at my minimum, x is 2. All right, I know going to the right is infinity, going all the way to the left is negative infinity. a lot of the ones we've done so far are shaped the same way, but it's okay. All right, so here's my increasing, decreasing. Okay, so we always start with the smallest number on the left. So what do you guys think the smallest number should be for this first one? It's going to be one of these numbers. What do y'all think? Negative infinity. Good. All right, and we're increasing all the way until we get to where x is 0, and then it switches. All right, we start increasing again when x is 2, and increase forever to the right, which is infinity. Okay, and then I have this small section of decreasing. That's going to be between 0 and 2. That's it. Okay, one more, and I'll let you guys finish it up on your own. So I'm going to go ahead and look at my relative maximum. I know that at my relative maximum, that x is 0. Now I have two relative minimums, so I know that this one is negative 1.84, the x is, and this one, the x is 1.09. Right side is infinity, left side's negative infinity. Okay, those are the only numbers we're going to use whenever we're given our intervals. Okay, so I can tell that if I'm going from left to right, this is increasing, this one's increasing. All right, this one's falling or decreasing, and so is this one. Okay, so I'm just going to use those numbers I've written on the graph to give my intervals. All right, so it looks like we're going to go from where x is negative 1.84 to 0 for one interval, and then 1.09 to infinity. All right, decreasing, we're going to go from negative infinity to negative 1.84. Bless you. And then from 0 to 1.09. All right, so what questions do you guys have? Feel free to grab some Sharpies, some highlighters if you want. I have several different colors, like 5 different colors. Okay, so this is what I want you guys to do. So on our note section, we still have 3, 4, 5. Go ahead and just do the intervals of increasing and decreasing on each of those. All right, and then on the homework section, so flip to like the last page. On 5 through 8, same thing. Do the intervals of increasing and decreasing. So really all that should be left that we haven't done on those problems today is the end behavior, which we'll learn about on Monday. All right, so just finish the notes that have the graphs, just increasing and decreasing sections. And then on the homework page, Unit 5, Homework 3, 5 through 8, increasing and decreasing.